Hi, I'm Lucia. I'm a PhD student from the University of Edinburgh. Today I will talk about using mood pattern in predicting depression symptoms.
Alex experiences a loss of appetite, low mood, and constantly feeling tired. He went to the doctor. The doctor checked his patient history and asked him about his thoughts and feelings. Eventually, Alex was diagnosed with depression. In recent years, scientists have been trying to use social media data to diagnose depression. They extract proxy signals from social media data and feed these signals to machine learning algorithms. These social media signals include medication names, asking for mental health support, and emotions from the social media text. Alex does have a social media account and posts regularly. However, he never mentions medication names nor asks for mental health support on his social media account. These are not typical behaviors for psychologists to evaluate whether a person has depression. Typical symptoms that psychologists would look at are sleep or mood patterns and symptoms that are documented in the diagnostic menu. So what can we infer from Alex's social media data then? Depression is a type of mood disorder, and the changing pattern of mood is critical for diagnosing depression. We can build a mood profile to observe signs of depression symptoms. But how can we find out what Alex's mood pattern is from his social media text? We need to start by observing the emotions expressed in his posts. Emotions are how you react to stimuli. It usually lasts from seconds to minutes. Mood lasts for hours to days. If you laugh many times a day, you're likely to have a good mood. Now, the first step is to extract emotions from social media posts. We did this by counting how often a user mentions words that show different emotions. Now we need to think about how to convert emotions to mood. We define the emotions in a period of time as mood. We call this period of time a time window. We don't know what is the appropriate size of the time window, so we try the different ones: 3 days, 7 days, or 14 days. Another question is, shall we use the most frequent emotion to represent mood, or shall we use the averaged emotion to represent mood? We don't know, so we try both. Now we have a mood representation. A mood representation is constructed using Alex's social media post 1 year before he filled out a scale to measure his depressive symptoms.
The mood representation also has the parameter called the slight increment. A slight increment is the step size of the time window when it moves along the vector. The time window, slight increment, and ways to define mood are 3 parameters for the mood representation. Next, we defined a mood momentum representation by computing the changes of mood between 2 time windows. We also defined a mood representation to represent the transition of mood states. We use categories to represent the transitions. For example, in a daily mood representation, transferring from a negative day to a positive day is represented as category 1. Transferring from a silence day to a negative day is represented as category 2. We have 16 categories in total for these mood representations.
By combining mood representations with different constructions, we build a mood profile for Alex. We also built a mood profile from 781 other social media users. These social media users were from the Facebook My Personality dataset. We applied to use this dataset back in 2017 for this study.
Here we show our participants have written more than 90,000 Facebook posts 1 year before they finished the depressive symptom scale. On average, each of them posted 120 posts. This figure shows their post count for 1 year. On average, our participants are 26 years old. 43% of them were male and 57% of them were female. Here are the ethnicity and marital status of our participants. We can see most of them are white, single women. People of other skin colors were highly underrepresented in this dataset.
These users also completed a scale that measures their depressive symptoms, called Center for Epidemiologic Studies Depression Scale.
The depressive symptom score ranged from 0 to 60.
The scale asks questions like how often you have felt lonely during the past week.
We also divided the users into two groups according to their depressive symptom scores. Those who have a score lower than 22 are categorized as low symptom, and those who were higher or equal to 22 were high symptoms.
Now we're going to test whether the mood profile is associated with depressive symptom levels. First, we use a Gaussian process regression to monitor mood fluctuation. What is Gaussian process regression? Suppose we want to find a linear relationship between x and y. We try to find a parameter to define the intercept and slope of the regression line. Gaussian process regression provides a probability approach to do this by updating the parameters when there's a new data point. In a Gaussian process regression, we have a parameter called length scale. The larger the length scale, the fewer fluctuations in the regression line. This is our result. We find that people with more depressive symptoms show more fluctuations in their mood. Now we use a hidden Markov chain model to test our mood representations. A hidden Markov chain model can estimate hidden states according to observed states. There are 4 observed states here: positive, negative, neutral, and silence. We define the day when a user did not post anything as silence. This is the advantage of using a hidden Markov chain model. We can model a silent state instead of putting nulls in the dataset. We use a mood representation with the time window of 1 day as input for the hidden Markov chain model. We set the model to estimate a corresponding binary hidden state for each day. We assume one of the hidden states represents high depressive symptoms and the other one represents low depressive symptoms. But how do we know which is which? The emission probability from the hidden states tells us how likely a hidden state emits an observed state. This is the emission probability of our model. We can see the low symptom states are more likely to emit positive emotions. The high symptom states are more likely to emit negative emotions. The most frequent state is silence, of course, because most of the people don't post stuff every day. Now we use the assumption that if users have one high symptom state in the past 1 week, a user has high depressive symptoms. We use precision and recall to measure how good the prediction is. Precision tells us among all the people predicted to have high symptom level, how many of them actually have it. Recall tells us that among all the people that have high symptom level, how many of them are predicted accurately? This is a result of our prediction model. If we assume high symptom users have one high symptom state in the past week, this is a result. If we assume high symptom users have 6 high symptom states in the past 2 weeks, this is a result.
Now we know the daily mood representation is associated with the depressive symptom level. Of course, we can also try weekly, bi-weekly, or monthly mood representation to infer symptom level states and see which one is better. However, we didn't do that because seeing which representation is better in a hidden Markov chain model is not the primary purpose in our study. Remember, the silence day is included in this modeling process. In the previous analysis, silence day was replaced by the mean value. The most important finding in this model is that silence day is also informative regarding the depressive symptoms. But why does this model have a low recall rate? We see that people who have high symptom level post more. But for people who have very severe depressive symptoms, it's likely that most of their daily mood is silence, because people who are very depressed just don't have the energy to do anything. We did some follow-up analysis. The median post count for participants with a low depressive symptom score, which is lower than 22, is 69. For those with high symptom score, which is higher than 22 but lower than 40, their median post count is 77. For those with extremely high symptom score, which is higher than 40, their median post count is 62. This is what we call the Simpson's paradox. The Simpson's paradox means the association of the same two variables can be different after controlling one or more other variables. In here, the control variable should be the symptom level. In this case, the model keeps estimating low symptom states for people with very high symptoms. People with very high symptoms accounts for 8% of the population in this sample. The way we use a hidden Markov chain model doesn't consider the Simpson's paradox, imposing behavior, and depressive symptoms. So this model is only applicable to a subset of a sample. But it gives us a nice estimation of symptoms on a very fine-grained level.
Finally, we use a logistic regression model to test which single mood representation is the best. We added each mood representation to a baseline model, and this is the result.
The first row is a random baseline. The second row is a baseline using LUIC, average sentiment, topic modeling, TF-IDF bag of words as features. The rest of them are adding each of our mood representation on top of the features of the second baseline. The window size for the experiments reported below is 14 days, with a slight increment of 7 days. Combining all the mood representations yields the highest F1 score. Finally, we conclude that the mood derived from social media text is associated with depressive symptoms. People with more depressive symptoms show more fluctuations in their mood pattern derived from social media text. We introduced features to represent the transition of mood states. These transitions turn out to be quite important. Our inspiration to construct these features comes from psychology literature, which emphasize that the changes in mood are critical symptoms of affective disorders. Now we see the representation for the changes of mood is critical for inferring symptoms. However, we also need to be aware of the Simpson's paradox between posting frequency and symptom level when we include the posting frequency in the mood representation. Meanwhile, time series analysis and temporal representation are critical for inferring affective symptoms. We do have some limitations in our study. For example, the sample biases in social media data. All these results are only applicable to people who use social media data. We also don't have a gold standard for depressive symptoms. Self-reported symptom level is not a diagnosed symptom, although it does reflect the mental health status of the users to a certain extent.
But most importantly, Alex can look at his mood pattern and say,
"Oh, it seems like I've been having low mood for the past 2.5 months.
When this happens, maybe it's time to talk to a counselor." For more details about the dataset, construction of the mood representation, and the baseline model, please click here to check our paper. And don't forget to subscribe our channel.